Hello everyone, and welcome to a lesson on modeling with functions. Before we talk about how to actually create these functions and how to actually create the equations, I want us to be able to just take a look at independent and dependent variables and know exactly what we're talking about there. So the word independent and dependent is actually very similar to input and output in a way. We have independent input. So when we dealt with input and output, domain and range before, we were always talking about independent dependent. It's just new words that mean the same thing. But in the case of dealing with more situations, independent dependent are more appropriate. So if you guys could go to page 127, A to F, we could talk about what independent dependent are using these examples right here. So in the case of this first situation, in the winter, more electricity is used when the outside temperature goes down, and less is used when the outside temperature rises. I want you guys to take a moment and pause the video, and I want you to take a look at these problems right here and figure out, okay, these words right here in the word bank, what's going to go where for all of these blanks, including what we just talked about. Just take a moment, pause the video, and actually try that yourself before I go over the answers.
Mic off. Mic on.
All right. Hopefully you guys went over this, and hopefully you took your time to try that. But let's go ahead and fill this out right here. So the situation with electricity and outside temperatures. It clearly is talking about the amount of electricity being used depending on how hot or cold it is the temperature. So in this case, if I was going to write a function, the dependent would be the amount of electricity and the independent would be the temperature, which kind of makes sense. Typically when we get into winter, people use the heater a lot and you tend to use a lot more electricity, while the summer you don't want to as much unless you're going to use the AC. Another example is, particularly at part C, guys. It says the cost of shipping a package is based on its weight. Once again, makes sense. The heavier a package is, the more the shipping company typically charges, right? It's not always based on size. A lot of times it's based on weight. So in this case, we'd say the cost depends on the weight. So the dependent would be cost, and then dependent would be weight. Let's do one more example. Let's talk about Tom. The faster Tom walks, the quicker he gets home. Makes sense. If you go for a walk really fast or really leisurely, then uh, you know, then it depends on how long your walk's going to be. So we could say that the time depends on the speed, which makes time dependent and speed independent. So all these little practice problems, guys, it's going to become important when we actually do to the actual word problems. Okay, so just keep in mind this idea of dependent, some sort of variable being influenced by another variable. Okay, so it's about function notation. Why are we doing this? Why can't we just stay as y equals 3x plus 7? Why do we have to do f of x equals 3x plus 7? Well, first let me actually show you how f of x is used. So if, for example, you're asked to find f of 2, what that means is you are going to replace all x values. It used to be f of x, now it's f of 2. All x values become 2. So let's just keep track of what we started with. And when I simplify this and I get 13, I know I started with 2. I put 2 into the function and out popped a 13. Then I know I haven't really answered the question yet of why we're using function notation. And it's like for this, guys. In the future, if you're someone who pursues a mathematical career and you're doing functions, your equations are not going to look this simple. You might look at something a bit more like this. It might look a lot crazier. But would you rather say, when you're talking about this equation for some sort of research project, wouldn't you rather say function g, which is what this letter right here is, versus saying the whole thing, this whole thing? It's just a nice little shortcut. If we had everything be y equals y equals y equals y equals, then it'd be harder for us to tell what we're talking about. But I could replace this f with a g or an h or a z, and it's like a label for that specific function. So that's just something for you to keep in mind. All right, so on page 129, we're going to go over an example of how we're going to actually represent a situation as a function. So this right here is the admission fee at a carnival is $9. Each ride costs $1.75. How much does it cost to go to the carnival and then go on 12 rides? So that's a lot of information right here. We're specifically asked, we obviously have a situation of like total cost versus how many rides you go on. If you guys have been to a carnival, they can be pretty neat. We have something similar to that, right? Which is like the yearly fair that we have at the fairgrounds, although that really happened this year. Anyways, the first step is when you have this situation, you should think about what is our independent and what is our dependent. And we're clearly talking about the total cost, and it depends on the number of rides plus $9, right? You have to pay $9 to get into the amusement park, and you have to pay $1.75 for every ride. So the total cost is always going to be based on the number of rides. You could probably already tell that the dependent ride is the total cost, and the independent is the number of rides. Now, when I create my function, guys, when I create my f of x, I could say f of x is the total cost, which is the dependent, and x is the number of rides. But you know what? X has nothing to do, the letter x has nothing to do with number of rides. Why don't I, instead of doing x, let's have r be the number of rides. You know, why not? So let's have that be f of r instead. So this is another thing that's nice about function notation, is I could change these variables to suit my purposes a little bit more. So if I was going to make an equation on this, since r represents the number of rides, the function for the total cost is $1.75 for every ride plus that $9 admission fee. So now I have my function. But that doesn't answer the question. The question doesn't ask us even to make a function, right? The question says, how much does it cost to go to the carnival and then go on 12 rides? So I can find, with f of r equals $1.75 r plus 9, I can replace r with 12. So I'm going to find f of 12 right here, and then I can solve it. 1.75 times 12, put that in your calculator, you get 21. 21 plus 9 is 30. So with this information, I know that if I put in 12 right here, I will get 30. 12 represents the number of rides, and 30 represents the total cost. So as a final statement, I could say it cost me $30 to go to the carnival and go on 12 rides. And that's how you want to really think about, guys, when you create these functions and how to represent situations with them. Think about first what the dependent and what the independent is, so you know how to set up the rest of the equation. Make sure you guys do the homework, and you have a good day. Bye.